Picture this. You're floating in a spaceship, gazing out at the vast expanse of the cosmos, when suddenly you notice something peculiar. Every beam of starlight reaching your eyes, every photon dancing across space, every whisper of electromagnetic energy in the universe, all of it moving at exactly the same speed. Not almost the same speed, not roughly the same pace, but precisely, unchangeably, beautifully the same. 209, 792, 458 meters per second. And here's the thing that might surprise you as you drift towards sleep tonight. This isn't just some cosmic coincidence or arbitrary rule the universe decided to follow. This speed limit, this cosmic constant we call the speed of light, is woven so deeply into the fabric of reality that without it, space and time themselves would simply fall apart. Now you might be wondering, as many curious minds have wondered before, why does light seem to be in such a hurry? Why does it race across the universe at nearly 300,000 kilometers every single second? And perhaps most intriguingly, why can't anything go faster? The answer, as we'll discover together on this gentle journey through the cosmos, is far more elegant and profound than you might imagine. You see, the speed of light isn't really about light at all. It's about the very architecture of space-time itself, the invisible scaffolding that holds our universe together. When we say nothing can go faster than light, we're not just describing a traffic rule for photons, we're revealing something fundamental about how information, energy, and causality flow through the cosmos. It's the difference between cause and effect, between yesterday and tomorrow, between here and there. Think of it this way. Imagine you're sitting by a still pond on a quiet evening, and you drop a pebble into the water. The ripples spread outward in perfect circles, carrying the information of that splash across the surface. The speed of light is like the speed of those ripples, but instead of moving across water, it's moving through the fabric of space-time itself. And just as those ripples can't travel faster than the medium allows, information in our universe can't travel faster than space-time permits. But here's where it gets beautifully strange. Light doesn't just follow this speed limit, it defines it. Those dancing photons, those packets of electromagnetic energy that bring us the warmth of sunlight and the twinkle of distant stars, they have no choice but to move at this cosmic speed. They can't slow down, they can't speed up, they can't even rest. From the moment they're born in the heart of a star to the moment they gently touch your retina, they're locked into this eternal, unwavering pace. This isn't because light is particularly ambitious or in a hurry to get somewhere. It's because light has no mass, no weight, no substance in the traditional sense. It's pure energy, pure motion. And in a universe where space-time itself has a maximum speed limit, massless particles like photons have no choice but to travel at that limit. They're not trying to go fast, they're simply following the only path available to them through the geometry of space-time. And this brings us to one of the most beautiful revelations in all of physics. The speed of light isn't just a property of light, it's a property of the universe itself. It's the speed at which causality propagates, the pace at which cause and effect ripple through space-time. It's the maximum speed at which information can travel, which means it's the speed that keeps the universe logical, ordered, and beautifully consistent. Now you might be thinking, surely something could go faster. What about those science fiction stories where spaceships zip across galaxies in the blink of an eye? Well, the universe has a gentle but firm way of saying no. As anything with mass approaches the speed of light, something remarkable happens. Time begins to slow down for that object, space begins to contract, and the energy required to go even a tiny bit faster approaches infinity. It's as if the universe is saying, you can get close, but you can never quite reach this sacred speed. This cosmic speed limit does something profound for our understanding of time and space. It means that simultaneity, that sense of things happening at the same moment, is actually relative. What seems simultaneous to you might not seem simultaneous to someone moving at a different speed. It means that time itself is flexible, stretching and compressing depending on motion and gravity. And it means that the universe has a built-in protection against paradoxes, ensuring that effects always follow causes, that the future always lies ahead of the past. But perhaps most wonderfully, this speed limit connects us to the cosmos in the most intimate way. Every beam of sunlight that has ever warmed your face, every photon that has ever carried the image of a loved one to your eyes, every particle of light that has travelled billions of years from distant galaxies to tell us stories of the ancient universe, all of it has made that journey at exactly the same speed. The light from the star you're seeing tonight left that star at precisely 292,458 meters per second, travelled through the vast emptiness of space at precisely that speed, and arrived at your eye at precisely that speed. In a universe that can seem chaotic and unpredictable, there's something deeply comforting about this constant. No matter where you are, no matter how fast you're moving, no matter what's happening around you, light will always greet you at the same speed. It's a cosmic handshake, a universal constant that reminds us that beneath all the complexity and mystery of existence, there are still rules, still patterns, still beautiful mathematical relationships that hold everything together. As you settle into sleep tonight, perhaps you'll dream of photons racing across the cosmos, carrying messages between stars, painting auroras in distant skies, and gently illuminating the face of some alien moon. And maybe, just maybe, you'll find comfort in knowing that all of this cosmic light show is happening at exactly the right speed. The only speed it could possibly happen at. The speed that makes our universe possible, predictable, and beautifully, eternally consistent. Sweet dreams, fellow traveller of space-time. The light will still be racing across the universe when you wake, moving at its perfect, unchanging pace, connecting us all to the vast, elegant dance of the cosmos. Looking at the cosmic vastness around us, we might wonder if there's something even more fundamental than the speed of light itself. You see, when physicists talk about light speed, they're not really talking about light at all. They're talking about the speed of causality, the speed at which cause and effect can propagate through the universe. Light just happens to travel at this speed because it has no mass, no choice in the matter. Think of it this way: the universe has a maximum speed limit built into its very structure, woven into the fabric of space-time itself. This isn't arbitrary, like a speed limit on a highway that could theoretically be changed. It's more like the universe saying, this is how fast information can travel, how quickly one event can influence another, and nothing can exceed this pace. This speed limit exists because of something profound about the nature of space and time. They're not separate entities, but part of a unified fabric called space-time. The speed of light is really the conversion factor between space and time, telling us how much space equals how much time in the universe's accounting system. When we measure distance in light years, we're not just being poetic, we're acknowledging that space and time are so intertwined that we can measure one in terms of the other. But here's where it gets beautifully strange. This cosmic speed limit doesn't just affect light, it affects everything. Every particle, every force, every whisper of information that travels through the cosmos must respect this boundary. Gravity, for instance, also travels at the speed of light. If the sun were to suddenly vanish, we wouldn't just keep seeing it for 8 minutes. We'd also keep feeling its gravitational pull for exactly the same amount of time. This creates what physicists call the light cone, a geometric way of thinking about what can influence what in the universe. Imagine you're standing in a field and you clap your hands. The light and sound from that clap can only influence things within an ever-expanding sphere around you. Anything outside that sphere exists in a kind of causal isolation until the signal reaches it. The universe, in its elegant wisdom, has built-in buffers that prevent chaos from spreading instantly across all of space. Now, you might wonder, Why this particular speed? Why not faster or slower? The answer lies in the fundamental constants of nature. The speed of light emerges from the relationship between electricity and magnetism, two forces that seemed separate until Maxwell showed they were part of the same phenomenon. When you do the mathematics of how electric and magnetic fields interact, out pops a speed. That speed is the speed of light. It's as if the universe had to choose this speed to remain consistent with itself. Make it any different, and the equations that govern electromagnetism would break down. Stars wouldn't shine, atoms wouldn't hold together, and the delicate dance of forces that makes chemistry possible would collapse into chaos. But there's something almost poetic about this limit. It means that the universe has built-in delays, moments of pause between cause and effect. When you look at the stars, you're not seeing them as they are now, but as they were when their light began its journey. The further you look, the further back in time you see. The speed of light doesn't just limit how fast things can go, it gives us access to history, letting us peer into the past by simply looking up at the night sky. This delay also prevents paradoxes. Without the speed of light limit, you could theoretically send information faster than light, and with enough cleverness, send messages into your own past. But the universe, in its quiet wisdom, prevents this by making the speed of light the absolute maximum. It's a cosmic guardrail that keeps causality flowing in one direction, from past to future, keeping the story of the universe coherent and logical. Even more remarkably, this speed limit creates a kind of cosmic democracy. No matter how fast you're moving, no matter where you are in the universe, you'll always measure light moving at exactly the same speed. This isn't just convenient, it's necessary for the universe to make sense. If different observers could measure different speeds for light, the laws of physics would be different in different places, and the universe would be an inconsistent, unpredictable place. Instead, the universe bends space and time themselves to preserve this constancy. Time slows down for fast-moving objects, distances contract, and the very fabric of reality reshapes itself to ensure that everyone, everywhere, always sees light moving at the same pace. It's as if the universe values consistency above all else, willing to warp the fundamental dimensions of existence to maintain this one unwavering constant. The speed of light isn't just a number in a physics textbook, it's the cosmic metronome that keeps the universe in rhythm, the universal translator between space and time, and the guardian of causality itself. It's the reason we can trust that effects follow causes, that the past stays behind us, and that the future remains ahead. In a universe full of variables and uncertainties, the speed of light stands as a constant, a fixed point around which everything else can dance. So when we ask why nothing can go faster than the speed of light, we're really asking why the universe has structure at all. The answer whispers back through the cosmic dark, because without this limit, there would be no story to tell, no order to discover, no gentle rhythm to guide us through the vast mystery of existence. The speed of light isn't just the fastest thing in the universe, it's the rule that makes the universe possible. Looking at light itself, we need to understand that it's not just one thing, but a fascinating dual personality that has puzzled scientists for centuries. Picture this. Light behaves like both a wave and a particle, depending on how you observe it. It's as if the universe is playing a cosmic game of hide and seek, revealing different aspects of light's true nature, based on what questions we dare to ask. Let's start with photons, those peculiar little messengers that make up light. Think of them as the universe's postal service, but with a twist about. These aren't particles in the way we usually imagine them, like tiny marbles bouncing around. Instead, they're packets of pure energy, with no mass whatsoever. They don't rest, they don't pause for coffee breaks, and they certainly don't follow the normal rules that govern everyday objects. A photon exists only in motion, And if it were to somehow stop, it wouldn't just be taking a breather. It would simply cease to exist entirely. But here's where it gets beautifully strange. These massless bundles of energy also behave as electromagnetic waves. Picture two invisible fields, one electric and one magnetic, dancing together in perfect harmony. They oscillate at right angles to each other and to the direction they're travelling, creating a kind of cosmic ballet that requires no stage, no medium, nothing at all to move through. While sound waves need air and water waves need water, light waves just go. They glide through the vacuum of space with an elegance that would make any dancer envious. This wave nature of light is what gives us the entire electromagnetic spectrum, that vast rainbow of energy that extends far beyond what our eyes can see. Visible light, the colours we perceive, represents just a tiny slice of this spectrum. Imagine a piano that stretches for miles and visible light is just a handful of keys, somewhere in the middle. On one end, we have radio waves, those long, lazy undulations that can stretch for kilometres. They're the gentle giants of the electromagnetic family, carrying our favourite songs and late-night talk shows across vast distances. Moving up the spectrum, we encounter microwaves, which do far more than just heat up yesterday's leftovers. They're busy carrying satellite communications and helping astronomers peer into the cosmic microwave background, that ancient afterglow of the Big Bang itself. Then comes infrared radiation, the warmth you feel from a fireplace, or the heat signature that shows up on thermal cameras. It's light we can't see but can certainly feel. Beyond visible light, we find ultraviolet radiation, that invisible energy from the sun that gives us both summer tans and the need for sunscreen. Higher up the spectrum are X-rays, those ghostly waves that can pass through your soft tissue but are stopped by your bones, creating those eerie skeletal images that have fascinated us since their discovery. And at the very top of the energy ladder, we have gamma rays, the most energetic form of light, usually found in the company of exploding stars and nuclear reactions. The remarkable thing is that despite this incredible diversity, all these forms of light travel at exactly the same speed in a vacuum. Radio waves and gamma rays, despite their vastly different energies and wavelengths, race through space at precisely 299,792,458 meters per second. It's as if the universe has one universal speed limit that applies to all forms of electromagnetic radiation, regardless of their individual characteristics. But light doesn't always maintain this breakneck pace. When it travels through materials like water, glass, or even the air we breathe, it slows down. This isn't because the photons themselves are getting tired, but because they're interacting with the atoms in the material. It's like trying to walk through a crowded room. You're still moving forward, but there's a lot more bumping and weaving involved. This slowing down is what causes refraction, the bending of light that makes a straw look bent in a glass of water or creates the spectacular sparkle of a diamond. What's fascinating is that even when light slows down in these materials, individual photons still travel at the same speed between atomic interactions. They're just taking a more complicated path, like someone trying to navigate through a dance floor full of enthusiastic relatives at a wedding. The overall journey takes longer, but each step is still taken at the same fundamental speed. This brings us to one of the most beautiful aspects of light, colour. When we see a rainbow or watch light pass through a prism, we're witnessing light reveal its hidden complexity. Each colour represents a different wavelength of visible light. Red light has long, lazy wavelengths, while violet light vibrates with short, energetic pulses. But they're all still photons, all still electromagnetic waves, just dancing to different rhythms. Your eyes are perfectly tuned to detect these different wavelengths. Special cells called cones in your retina are sensitive to specific ranges of light, and your brain interprets these signals as the rich tapestry of colours you see every day. In a way, colour isn't really a property of objects themselves. That red apple isn't inherently red. Instead, it's absorbing most wavelengths of light while reflecting back the ones we interpret as red. Colour is your brain's elegant translation of electromagnetic vibrations into the visual symphony of the world around you. The massless nature of photons leads to another profound truth. Light has no choice but to move. Unlike you or me or even the smallest grain of sand, photons cannot be at rest. They exist only in motion, forever travelling at their designated speed. If a photon were to somehow stop, it wouldn't just be pausing for a moment, it would cease to exist entirely. Motion isn't just what light does, it's what light is. This creates a strange and beautiful paradox. Light, which has no mass and no substance in the traditional sense, is responsible for everything we see. It carries information about distant stars, illuminates the faces of those we love, and brings colour to our world. It's the medium through which we experience vision. Yet it's made of nothing but energy in motion. As we drift towards sleep tonight, consider this. Every photon that reaches your eyes has travelled its entire existence at exactly the same speed, whether it came from the lamp beside your bed or from a star billions of light years away. These tireless messengers of light have been racing through space and time, carrying stories of the universe directly to you. They've never rested, never slowed down by choice, and never deviated from their cosmic purpose of connecting all things through the simple act of illumination. Light isn't just what helps us see, it's how the universe speaks to us, one photon at a time, in a language written in wavelengths and frequencies, telling us stories of both the infinitely distant and the intimately near. Light moves at exactly 209 792 358 meters per second in a vacuum. And that number isn't just a cosmic coincidence. It's woven into the very fabric of reality itself, emerging from the fundamental constants that govern electricity and magnetism. But here's where things get wonderfully strange. Light doesn't just happen to travel at this speed, it defines what this speed means. Think of it this way. When James Clerk Maxwell first unified electricity and magnetism in the 1860s, he discovered something extraordinary hidden in his equations. The mathematics predicted that electromagnetic waves would naturally propagate at a specific velocity, and when he calculated that number, it matched the measured speed of light perfectly. This wasn't coincidence, it was revelation. Light, Maxwell realized, was an electromagnetic wave, and its speed was dictated by the electric and magnetic properties of empty space itself. Those properties, called the electric permittivity and magnetic permeability of free space, are like the universe's electrical and magnetic resistance. They determine how electric and magnetic fields interact with the vacuum, and their values directly control how fast electromagnetic waves can travel. It's as if the universe has built-in speed limits based on its own fundamental architecture. But Maxwell's discovery was just the beginning. Einstein took this insight and pushed it further, showing that the speed of light isn't just the speed of electromagnetic radiation. It's the speed of causality itself, the maximum rate at which any information or influence can travel through space. This cosmic speed limit emerges from the geometry of space-time, ensuring that cause always precedes effect, and preventing the logical paradoxes that would arise if information could travel instantaneously. The beautiful thing is that this speed limit protects the universe from chaos. Without it, you could theoretically send signals into the past, creating grandfather paradoxes and timeline loops that would unravel the very concept of cause and effect. Instead, the speed of light maintains order, keeping the universe logically consistent and mathematically elegant. What's truly remarkable is that this speed isn't arbitrary. It's precisely what it needs to be to allow the universe to function as a coherent, stable system. The speed of light connects space and time, energy and momentum, the local and the cosmic. It's the conversion factor that lets us translate between different aspects of reality, the universal constant that makes physics possible. And here's perhaps the most profound part. Photons themselves experience none of this. From a photon's perspective, if it could have one, it's created and absorbed in the same instant. Time doesn't pass for something moving at the speed of light. The photon exists only in motion, only in the act of connecting one moment to another, one place to another. It's the universe's messenger, carrying information at the maximum possible speed while experiencing no time at all. So when we ask why light travels at the speed it does, we're really asking why the universe has the structure it has. The speed of light isn't just a property of photons, it's a fundamental aspect of space-time itself, a reflection of the deep mathematical relationships that govern reality. Light moves at this speed because space and time are woven together in a very specific way, and that weaving determines the maximum rate at which anything can happen. In a sense, the speed of light is the universe's heartbeat, the rhythm that keeps everything synchronized. It's fast enough to connect distant galaxies and slow enough to give us time to think, to wonder, to gradually piece together the elegant laws that govern our cosmic home. And perhaps that's the most beautiful thing of all. In a universe vast beyond comprehension, light travels at exactly the right speed to let us see the stars. You've already established light's unique properties as a massless, restless traveller bound to the universal speed limit. Now we must explore what happens when this limit isn't just a curious fact, but the very backbone of reality itself, shaping how information flows through the cosmos and determining what can influence what, where, and when. Think of the universe as a vast web of connections, with every star, planet, and particle linked by invisible threads of causality. These threads can only stretch as far as light can travel, creating boundaries around what can affect what else in the cosmos. When you light a candle in your room, that tiny flame sends photons racing outward in all directions. But those photons can only influence what they can reach. Someone standing on a distant planet won't see your candle until the light has had time to cross the emptiness between you. Until then, as far as the universe is concerned, your candle might as well not exist for them. This creates what physicists call light cones, though they're less like ice cream cones and more like the expanding sphere of influence around every event in space-time. Picture dropping a pebble into a still pond. The ripples spread outward in circles, but they can only affect what they can reach. Light works similarly, except instead of ripples in water, we're talking about the very fabric of cause and effect rippling through space-time at exactly 299,792,458 meters per second. The profound implication is that the universe has no universal now. There's no cosmic clock ticking away somewhere that synchronizes all events across the galaxy. Instead, every point in space has its own local now, and these nows can only communicate with each other at light speed. This means that simultaneity, the idea that two things happen at the same time, becomes relative. What appears simultaneous to you might not appear simultaneous to someone moving at a different speed or in a different gravitational field. This relativistic nature of time isn't just theoretical, it's quietly working in the background of your daily life. The GPS satellites orbiting Earth experience time slightly differently than you do on the surface. They're moving fast, which slows their clocks down according to special relativity, but they're also higher up in Earth's gravitational field, which speeds their clocks up according to general relativity. The net effect is that their clocks run about 38 microseconds fast each day compared to Earth-based clocks. That might sound tiny, but without correcting for this difference, your GPS would be off by several kilometers within hours. Consider what this means for our understanding of the cosmos. When you look up at the night sky, you're not seeing the universe as it is now, but as it was. The light from the nearest star, Alpha Centauri, takes over 4 years to reach us. The light from the Andromeda Galaxy, our nearest galactic neighbour, left that galaxy over 2 million years ago, when early humans were just learning to use stone tools. Look deeper into space, and you're seeing light that left distant galaxies billions of years ago, before our sun even existed. This delay in information isn't a bug in the universe's design. It's a feature. It's what preserves causality, the logical order where causes precede effects. Without this speed limit, you could theoretically send a signal faster than light to a distant location, have it bounce back, and receive it before you sent it. This would create paradoxes that would unravel the logical structure of reality itself. The speed of light acts as a cosmic safeguard, ensuring that effects always follow causes and that the universe maintains its logical consistency. The limit also shapes how we understand influence and connection across the cosmos. Imagine 2 distant galaxies so far apart that light from one hasn't had time to reach the other since the beginning of the universe. These regions are causally disconnected, meaning they've never been able to influence each other. They exist in completely separate causal zones, like isolated islands in an ocean of space-time. This helps explain some puzzling observations in cosmology, such as why the cosmic microwave background radiation appears so uniform across the entire sky, even though distant regions seemingly never had time to communicate and reach thermal equilibrium. But perhaps most beautifully, this speed limit gives the universe its narrative structure. It creates a clear distinction between past, present, and future. The past is everything that could have influenced your current moment, the region of space-time from which light has had time to reach you. The future is everything you could potentially influence, the region of space-time that your light signals could reach, and the present is that thin slice of space-time where you exist, constantly moving forward, constantly writing new chapters in the cosmic story. This temporal architecture affects everything from the grand dance of galaxies to the intimate conversations between neurons in your brain. Every thought you think, every decision you make, every photon that bounces off this page and into your eyes is part of an unbroken chain of causality that stretches back to the earliest moments of the universe and forward to its distant future. The speed of light isn't just a limit, it's the thread that weaves all of these moments together into a coherent, understandable tapestry. So when you next see sunlight streaming through your window, remember that those photons began their journey 8 minutes ago, traveling through the vacuum of space at exactly the speed that allows causes to precede effects, that gives time its direction, and that keeps the universe's story coherent. They're not just bringing you warmth and light, they're carrying the fundamental structure of reality itself, one photon at a time, at exactly the speed that makes everything possible. Now we venture into perhaps the most mind-bending realm of all, where space and time themselves become the canvas on which light paints its eternal story. We've explored light as waves and particles, we've measured its relentless pace, and we've marveled at its cosmic choreography. But there's something even more profound at work here, something that transforms light from merely fast-moving energy into the very thread from which the universe weaves its fabric. You see, light doesn't just travel through space and time, it helps define what space and time actually are. This isn't poetic license or philosophical meandering. This is the breathtaking reality that emerges when we truly understand what that speed limit means, why it exists, and how it shapes every moment of existence, from the quantum to the cosmic. Let's begin with a gentle thought experiment. Imagine you're holding a flashlight in the deepest void of space, far from any stars or planets. You click it on, and photons stream out in all directions at that familiar speed of 458 meters per second. But here's the extraordinary thing. Those photons don't just carry light, they carry information. They carry the story of when they were emitted, from where and with what energy. Each photon is like a tiny messenger, and the speed of light is the maximum rate at which any message can be delivered anywhere in the universe. This speed limit isn't just a quirk of electromagnetic waves, it's the fundamental speed of causality itself. It's the pace at which cause and effect can ripple through reality. When you flip a switch, the electrical signal travels at close to light speed. When you speak, your words travel as sound waves much slower than light, but the electromagnetic fields that carry your voice through a phone move at light speed. When a star explodes in a distant galaxy, the information about that explosion, the light, the gravitational waves, the cascade of particles, all travel at or below the speed of light. This creates what physicists call the cosmic speed limit for information. Nothing can send a signal, carry a message, or influence anything else faster than light can travel. And this simple fact has profound implications for the structure of reality itself. Consider what this means for simultaneity, the idea that two events happen at the same time. In our everyday experience, simultaneity seems obvious. If two clocks in your room both show 3 p.m., then it's 3 p.m. for both of them, right? But Einstein's relativity tells us something much stranger. Simultaneity is relative. Two events that appear simultaneous to one observer might not be simultaneous to another observer moving at a different speed. This happens because information about when something occurred can only travel at light speed. If you're moving very fast relative to two distant events, the light from those events reaches you at slightly different times, even if the events themselves were simultaneous in some other reference frame. It's as if time itself has become elastic, stretching and compressing depending on your motion and position. But this isn't just an abstract curiosity. It's built into the very fabric of space and time. Space and time aren't separate entities. They're woven together into what we call space-time. And the speed of light is the exchange rate between space and time, the cosmic conversion factor that lets the universe translate distance into duration and back again. Think about it this way. When we measure distances in light years, we're already using this exchange rate. 1 light year isn't a measure of time, it's a measure of distance, specifically the distance light travels in 1 year. The fact that we can use a time-based unit to describe space, and that this makes perfect sense, reveals something fundamental about the nature of reality. Space and time are different aspects of the same underlying structure. This unity of space and time explains why nothing can go faster than light. It's not that light is special in some arbitrary way, it's that light travels at the speed of space-time itself. When physicists talk about the speed of light, they're really talking about the speed of causality, the speed of information, the speed at which the universe can update itself. Imagine space-time as a vast ocean and events as ripples spreading across its surface. The speed of light is the speed at which these ripples can travel. No matter how much energy you put into creating a ripple, it can't move faster than the medium allows. The ocean of space-time has its own inherent properties, its own speed limit, and that limit is what we call the speed of light. This helps explain why massive objects can't reach light speed. As you accelerate something with mass, you're not just making it go faster, you're trying to push it through the fabric of space-time itself. The faster you go, the more the fabric resists. Near light speed, this resistance becomes enormous, requiring infinite energy to push through to light speed itself. Only massless particles, like photons, can travel at this fundamental speed because they don't have to push through the fabric. They are part of the wave pattern of space-time itself. But here's where it gets truly beautiful. This cosmic speed limit doesn't constrain the universe, it liberates it. Without this speed limit, causality would break down. Effects could precede their causes. The logical structure of reality would collapse into paradox and contradiction. Instead, The speed of light creates a kind of cosmic order, a way for the universe to maintain its integrity across vast distances and long periods of time. This is why light isn't just electromagnetic radiation, it's the pulse of reality itself. Every photon carries with it the rhythm of space-time, the heartbeat of the cosmos. When sunlight touches your face, you're not just feeling warmth, you're experiencing the universe's way of connecting distant events, of carrying information across the void, of maintaining the delicate balance between cause and effect. The speed of light creates what we call light cones, regions of space-time that define what can influence what. Everything that can affect you right now lies within your past light cone, the region from which light has had time to reach you. Everything you can influence lies within your future light cone, the region to which your light can travel. Outside these cones lies a realm of events that are space-like, separated from you. They exist, but they cannot affect you, nor can you affect them, at least not yet. This creates a kind of cosmic democracy. No matter how powerful you are, no matter how advanced your technology, you cannot influence events outside your light cone. The universe has built-in protection against instantaneous action at a distance, against the kind of influence that would violate causality and create paradox. And yet, within these constraints, the universe is incredibly rich and dynamic. Light carries energy, information, and beauty across vast distances. It connects stars to planets, eyes to objects, past to present. It allows the universe to be knowable, to have structure, to tell stories that unfold over time. The speed of light is thus not just a physical constant, it's the speed of story itself, the pace at which the universe can narrate its own existence. Every beam of light is a sentence in the cosmic story. Every photon, a word carrying meaning from one part of reality to another. When you look at the stars tonight, remember that you're not just seeing distant suns, you're reading the universe's autobiography, written in light and delivered at exactly the speed that allows stories to make sense, causes to precede effects, and the cosmos to maintain its beautiful, logical, comprehensible structure. Light doesn't just illuminate the world, it creates the very possibility of a world that can be illuminated, understood, and shared. In the end, the speed of light isn't just about how fast photons travel. It's about how fast meaning itself can move through the universe, carrying with it the eternal conversation between matter and energy, space and time, cause and effect. Now we dive into one of the most fascinating aspects of our cosmic speed limit, and it's something that will gently reshape how you think about the universe itself. You see, the speed of light isn't just a number that photons happen to obey. It's something far more profound, far more fundamental. It's the speed at which reality itself operates, the cosmic heartbeat that governs not just light, but the very fabric of space and time. Let me paint you a picture that might seem strange at first, but bear with me as we drift into this beautiful idea. The speed of light, that familiar 792,458 meters per second, isn't really about light at all. It's about something much deeper. It's the speed at which cause and effect can travel through the universe. It's the maximum rate at which information, energy, and influence can flow from one point to another. Light just happens to be the messenger that travels at this fundamental speed, but the speed itself belongs to the universe. Think of it this way. Imagine the universe as a vast network, like the internet, but instead of cables and routers, it's made of space and time themselves. Every point in this network can only communicate with other points at a certain maximum rate. That rate, that cosmic bandwidth limit, is what we call the speed of light. But it's not just light that travels at this speed. It's the speed of causality itself, the speed at which one event can influence another. This is why physicists sometimes call it the speed of information, or more poetically, the speed of space-time. When Einstein worked out his theories of relativity, he discovered that space and time aren't separate things, but are woven together into a single fabric called space-time. And this fabric has a built-in speed limit, a maximum rate at which disturbances can propagate through it. Light, being massless, naturally travels at this maximum speed, but the speed limit itself is a property of space-time, not of light. Here's where it gets wonderfully strange. Because this speed limit is built into the very structure of reality, it creates what physicists call light cones. Imagine you're sitting in a quiet room and you clap your hands. The sound of that clap can only travel so fast through the air, reaching different parts of the room at different times. Similarly, the influence of any event in the universe can only spread at the speed of light, creating an expanding sphere of causality. This means that every moment in your life exists within its own light cone, a region of space-time that defines what can influence you and what you can influence. Events outside your light cone might as well not exist yet, because no signal, no force, no information from them can reach you. It's as if the universe has drawn gentle boundaries around each moment, saying, this is what matters now, this is what you can affect, and this is what can affect you. The speed of light creates what we call the relativity of simultaneity. Two events that appear to happen at the same time to you might not appear simultaneous to someone moving at a different speed. This isn't just a quirk of perception, it's a fundamental feature of reality. There is no universal now that applies everywhere in the universe. Instead, simultaneity is local, personal, relative. The speed of light enforces this by setting the maximum rate at which any two events can be connected. And here's something that might make you pause and smile. Because light travels at this fundamental speed, it experiences something quite remarkable. From the perspective of a photon, its journey is instantaneous. It doesn't experience time passing at all. The moment it's emitted from a star and the moment it reaches your eye are the same moment from the photon's point of view. In a sense, every beam of light exists in an eternal present, connecting distant points in space and time, without itself experiencing duration. This helps explain why light has such a special relationship with the universe. It's not just travelling through space-time, it's travelling along the boundary between space and time, at the precise speed where time stops and space becomes infinite. Light exists at the edge of possibility, at the cosmic speed limit, where the normal rules of physics reach their most extreme expression. The speed of light also determines the structure of electromagnetic radiation itself. When you think about it, light is just one small part of the electromagnetic spectrum, but all electromagnetic waves, from radio waves to gamma rays, travel at the same speed in a vacuum. This isn't coincidence. It's because they're all disturbances in the same fundamental field, the electromagnetic field, and that field can only propagate at the speed of space-time itself. Even the way we measure distance has become tied to this cosmic constant. Since 1983, the meter has been defined not as a physical object, but as the distance light travels in a specific fraction of a second. We've essentially made the speed of light the ruler by which we measure the universe. It's become our cosmic yardstick, our universal reference point. And this brings us to perhaps the most beautiful aspect of all. The speed of light doesn't just govern the behavior of photons zipping through space. It governs the rate at which the universe can know itself. Every star you see in the night sky, every galaxy captured by our telescopes, every bit of information we have about the cosmos beyond our solar system has arrived at exactly this speed. The universe's ability to be observed, to be understood, to tell its story is limited and shaped by this one fundamental constant. So when you see a sunset painting the sky in gentle colours, or watch starlight twinkling in the darkness, remember that you're witnessing something far more profound than just illumination. You're seeing the universe operating at its most fundamental level, at the speed of causality itself. You're watching information flow at the cosmic speed limit, carrying stories from distant stars and distant times, all arriving at your eyes at exactly 299,792, 458 meters per second. The speed of light isn't just fast, it's the speed at which the universe thinks, the speed at which reality unfolds, the speed at which one moment leads to the next, and perhaps that's the most comforting thought of all. In a universe that can seem vast and mysterious, there's something beautifully consistent about this cosmic speed limit, this gentle boundary that gives structure to space and time, and allows the universe to tell its story, one photon at a time. Now let me weave together the threads of our cosmic journey and reveal perhaps the most profound truth about light's speed limit. We've wandered through the mechanics of photons, traced the historical quest to measure their pace, and marveled at how this universal constant shapes everything, from your morning GPS directions to the vast architecture of space-time itself. But there's something deeper here, something that connects the smallest quantum whisper to the grandest galactic dance. You see, the speed of light isn't just a number written in the universe's rulebook, it's the very heartbeat of reality, the cosmic metronome that keeps everything in sync. When we say nothing can travel faster than light, we're really saying that information itself has a speed limit. And this limitation, far from being a cosmic inconvenience, is what gives the universe its beautiful, logical structure. Think about it this way. If information could travel instantly across any distance, cause and effect would become meaningless. You could know the outcome of events before they happened, send messages to your past self, and create paradoxes that would unravel the very fabric of logic. Instead, the speed of light creates what physicists call light cones, regions of space-time that define what can influence what and when. Imagine you're sitting in a quiet field at night, looking up at the stars. Every photon that reaches your eyes has been traveling for years, decades, sometimes millions of years to get there. You're not seeing the universe as it is now. You're seeing its history, layer upon layer of cosmic time unfolding in real time. The nearest star you can see is showing you what it looked like over 4 years ago. The Andromeda Galaxy is presenting itself as it was when early humans were just learning to use tools. This creates something wonderfully poetic. The universe is essentially telling us its story through light, one photon at a time. Every beam carries information about where it came from, what it encountered along the way, and the conditions that shaped its journey. The reddish glow of a distant galaxy tells us it's moving away from us, carried by the expansion of space itself. The specific colours missing from a star's light reveal what elements are burning in its core. The gentle microwave radiation that fills all of space whispers to us about the universe's birth nearly 14 billion years ago. But here's where it gets truly beautiful. This speed limit doesn't just govern light, it governs all information, all change, all possibility. When you make a decision, when you move your hand, when you think a thought, the effects of these actions ripple outward at the speed of light. Not the photons themselves necessarily, but the information about what you've done. The electromagnetic fields in your brain, the gravitational effects of your movements, the quantum entanglements that connect you to the rest of the universe. All of these propagate at light speed. This means that, in a very real sense, you're always living on the edge of a growing sphere of influence. Everything you do creates ripples that spread outward at 229 unwind, 792, 458 meters per second, carrying information about your actions into the future. And everything that affects you comes from similar spheres of influence, centered on other events, other people, other moments in space-time. The speed of light, then, is not just about light. It's about the fundamental rate at which reality updates itself. It's the universe's refresh rate, the speed at which new information becomes available, the pace at which the future becomes the present. Without this limit, the universe would be a chaotic place where everything happened at once, where there was no progression, no causality, no story to tell. And perhaps most remarkably, this speed limit is what makes us possible, the complex dance of electromagnetic forces that holds atoms together, the careful balance of energies that allows stars to shine for billions of years, the delicate timing that lets chemical reactions proceed in living cells. All of this depends on the fact that information travels at a finite speed. If the universe updated itself infinitely fast, none of these processes could exist. There would be no atoms, no stars, no planets, no life, no consciousness to contemplate these mysteries. So when you see a sunset painting the sky in brilliant oranges and reds, remember that you're witnessing something profound. Those photons left the sun about 8 minutes ago, carrying with them the story of nuclear fusion in the solar core, the dance of atoms in the sun's atmosphere, and the journey through 93 million miles of space. They've travelled at the only speed they can, the speed that keeps causality intact and allows the universe to unfold in its stately, logical progression. The speed of light is not a barrier, it's a gift. It's what gives time its arrow, space its structure, and reality its coherence. It's the thread that weaves together the quantum and the cosmic, the immediate and the eternal, the here and the everywhere. It connects your heartbeat to the pulse of distant pulsars, your thoughts to the birth of galaxies, your existence to the fundamental laws that govern all existence. And in those quiet moments when you're drifting off to sleep, as photons from your bedside lamp gently bounce off these words and travel to your eyes, remember that you're participating in the universe's greatest story. You're both the observer and the observed, the reader and the read, connected to everything that was, is, and will be by the gentle, constant, unbreakable speed of light. Tonight, as you close your eyes and let consciousness fade into dreams, know that even in darkness, even in sleep, the universe continues its ancient dance at exactly the right speed. Not too fast, not too slow, but at the perfect pace that allows stories to unfold, hearts to beat, and minds to wonder at the beautiful mystery of it all. Think of light as the universe's constant companion, the one thing that never changes no matter where you are or how fast you're moving. We've discovered that light doesn't just illuminate our world, it defines the very structure of reality itself. Every photon that reaches your eyes has travelled at exactly the same speed, whether it began its journey from the lamp beside your bed or from a star that died billions of years ago. The speed of light isn't arbitrary, it's woven into the fundamental equations that govern electricity and magnetism. When Maxwell first derived his equations in the 1860s, he found that electromagnetic waves, which include light, must travel at a specific speed determined by the basic properties of empty space itself. This isn't just a coincidence, it's the universe revealing one of its deepest truths. Light travels at the speed it does because that's the only speed at which the fabric of space and time can carry electromagnetic energy. But here's where it gets beautifully profound. The speed of light isn't just about light at all, it's the speed of causality itself, the maximum rate at which cause and effect can propagate through the universe. When Einstein showed us that nothing with mass can reach this speed, he was revealing a cosmic speed limit that protects the logical structure of reality. Without this limit, effects could precede their causes, creating paradoxes that would unravel the very concept of time as we know it. This cosmic speed limit shapes everything around us in ways both subtle and profound. It determines how GPS satellites must correct their clocks to account for the warping of time. It governs the delay in our internet connections as signals race through fibre optic cables. It's why we see lightning before we hear thunder, and why the stars we see at night are actually windows into the past, showing us not what the universe is, but what it was. The speed of light also creates what physicists call light cones, invisible boundaries that define what events can influence each other. Every moment you experience sits at the center of your own light cone, connected to some events in the universe, but forever separated from others. This isn't just a mathematical curiosity, it's the architecture of reality itself, ensuring that the universe remains comprehensible and causally ordered. Perhaps most remarkably, from light's own perspective, time doesn't pass at all. A photon emitted from a distant galaxy billions of years ago experiences its entire journey to your eye as a single, instantaneous moment. In a very real sense, light exists outside of time, serving as a bridge between moments and connecting the universe's past to its present in an eternal now. This helps us understand why the universe seems to protect this speed so fiercely. As objects with mass approach the speed of light, they require ever more energy to accelerate further. At the speed of light itself, the energy requirement becomes infinite, creating an impenetrable barrier. It's as if the universe is saying that this speed is reserved for something special, something that connects all moments and all places without ever resting, without ever slowing down. The constancy of light's speed also reveals something profound about the nature of space and time themselves. They're not separate, independent things, but aspects of a single, unified fabric that bends and stretches to ensure that light always travels at the same speed for every observer. When you move quickly through space, time slows down for you. When you're in a strong gravitational field, time dilates. These aren't just curious effects, they're the universe's way of maintaining the sacred constancy of light's speed. In our daily lives, we're surrounded by the quiet work of electromagnetic radiation, the warmth of sunlight on your skin, the radio waves carrying music to your car, the microwaves heating your dinner, the X-rays revealing the structure of your bones. All of these are forms of light, all traveling at the same fundamental speed, all obeying the same cosmic law that governs everything from the smallest atom to the largest galaxy. The speed of light connects us to the cosmos in the most intimate way possible. The iron in your blood was forged in the heart of a dying star, and the light from that stellar furnace carried the news of its creation across vast distances of space and time. The calcium in your bones, the carbon in your cells, all of it was once part of stellar processes that announced themselves to the universe through light, travelling at its patient, unchanging pace. This speed limit also gives us the gift of perspective. Because light takes time to travel, we can see into the past simply by looking outward. The further we peer into space, the further back in time we see. This cosmic archaeology, made possible by light's finite speed, has revealed the history of the universe itself, from the cosmic microwave background that whispers of the Big Bang to the light of the first stars that formed in the cosmic dawn. So when we ask why nothing can go faster than the speed of light, we're really asking why the universe has the structure it does. The answer isn't just about physics, it's about the deep harmony that makes existence possible. Light speed isn't a limitation, it's a gift. It gives us time, it gives us causality, it gives us the ordered flow of moments, from past to future. It connects every point in space to every moment in time, weaving the fabric of reality itself. Tonight, as you rest, remember that light is still travelling, still carrying messages between the stars, still connecting the universe in its ancient, patient way. And in that constancy, in that unwavering dedication to a single, sacred speed, lies one of the most beautiful truths about the cosmos we call home. Now here we are at the edge of a profound realization. We've journeyed through the mechanics of light, traced its history, and marveled at its constancy. But what if I told you that the speed of light isn't just about light at all? What if this seemingly arbitrary number, 299, 792,458 meters per second, is actually the fundamental speed of causality itself, the cosmic speed limit that governs not just photons but the very fabric of information, influence, and existence. This is where our story takes its most beautiful turn. You see, the speed of light isn't really the speed of light, it's the speed of space-time itself. It's the universal conversion rate between space and time, the cosmic constant that maintains the delicate balance between cause and effect. Light simply happens to be the most famous traveller at this speed, but it's not the only one. Think about it this way. When we say nothing can go faster than the speed of light, we're really saying nothing can go faster than the speed at which the universe processes information. Every interaction, every force, every whisper of influence between particles must respect this limit. It's as if the universe has a built-in processing speed, and that speed is what we call the speed of light. Consider gravitational waves, those ripples in space-time itself that occur when massive objects accelerate. When two black holes spiral into each other, they create waves that propagate outward at exactly the speed of light. Not because they are light, but because they are disturbances in the same fabric that light travels through. The universe is telling us that whether you're a photon, a gravitational wave, or any other massless messenger, you all travel at the same fundamental speed. Even more remarkably, this speed emerges from the basic properties of empty space itself. The vacuum isn't truly empty. It's filled with something called the quantum field, a seething ocean of virtual particles popping in and out of existence. The speed of light is determined by two fundamental properties of this quantum vacuum: its electric permittivity and its magnetic permeability. These aren't arbitrary numbers. They're the universe's way of defining how space and time relate to each other. Maxwell's equations, those elegant mathematical descriptions of electricity and magnetism, predicted this speed before anyone knew what it meant. They revealed that electromagnetic waves, including light, must travel at a specific velocity determined by the fundamental structure of space itself. It's as if the universe had already decided on this speed long before there were stars to shine or eyes to see. This brings us to something truly profound about the nature of reality. The speed of light isn't just a speed limit, it's the universe's way of maintaining causality, ensuring that cause always precedes effect, that the past stays in the past and the future remains ahead of us. Without this limit, the logical structure of the universe would collapse. Events could influence their own causes, creating paradoxes that would unravel the very notion of time and sequence. But there's something even more beautiful happening here. This speed limit creates what physicists call light cones, regions of space-time that define what can influence what. Every event in the universe sits at the center of its own light cone, and only things within that cone can affect or be affected by that event. It's a cosmic boundary that separates the possible from the impossible, the connected from the isolated. These light cones overlap and intersect, creating a vast web of causality that connects every moment to every other moment in a logical, ordered way. The speed of light isn't just setting a limit, it's weaving the fabric of existence itself, creating a universe where stories can unfold, where causes lead to effects, where the past informs the present and the present shapes the future. And here's where it gets truly poetic. From the perspective of a photon, from light's own point of view, time doesn't pass at all. A photon experiences no duration between its emission and absorption. It exists in a kind of eternal present, touching every moment of its journey simultaneously. In a sense, light exists outside of time, while being the very thing that gives time its structure for the rest of us. This is why light is so special. It's not just electromagnetic radiation zipping through space, it's the universe's way of maintaining its own coherence, its own logical consistency. Every beam of sunlight, every radio wave, Every X-ray is participating in this cosmic dance of causality, carrying information at the maximum speed the universe allows, connecting moments and places and events in the grand tapestry of existence. So when you see light streaming through your window tomorrow morning, when you notice the gentle glow of stars in the evening sky, remember that you're witnessing something far more profound than illumination. You're seeing the universe's heartbeat, the fundamental rhythm that keeps time flowing forward, that maintains the distinction between cause and effect, that allows the cosmos to tell its story in an orderly, beautiful way. The speed of light isn't just about light, it's about the deep structure of reality itself, the invisible foundation upon which everything else rests. It's the universe's way of saying that while space and time may be flexible, while reality may be strange and wonderful, and full of surprises, there are still rules, still boundaries, still a fundamental order that keeps everything from dissolving into chaos. And in that order, in that beautiful, unwavering constancy, we find not a limitation, but a gift. The speed of light gives us a universe where meaning is possible, where stories can unfold, where the gentle progression from moment to moment creates the space for consciousness, for wonder, for the very thoughts you're thinking right now, as you drift towards sleep, cradled by the cosmic rhythms that light helps maintain. As we reach the final stretch of our gentle voyage through time, we find ourselves at a curious crossroads. We've explored the ticking of atomic clocks and the warping of space-time. We've followed Einstein's revelations and pondered the nature of causality itself. But now, as we prepare to drift toward the end of our journey, there's one last profound question that deserves our quiet attention. What does it all mean for us, here, now, in this moment? The speed of light, as we've discovered, is far more than just a number on a physics textbook. It's the cosmic speed limit, yes, but it's also the thread that weaves together the very fabric of reality. It defines the structure of space-time, governs the flow of causality, and sets the rhythm by which the universe dances. Every photon that reaches your eyes, every electromagnetic wave that carries your late-night messages, every beam of starlight that whispers stories from distant galaxies, all of it moves at this one sacred pace. But perhaps the most beautiful aspect of this cosmic constant is how it connects us to something larger than ourselves. When you look up at the night sky, you're not just seeing distant suns, you're witnessing the universe's own history book, written in light and delivered at exactly the right speed to tell its story. The light from the nearest star took over 4 years to reach you. The glow from distant galaxies has been travelling for billions of years, carrying with it the fingerprints of cosmic events that happened long before our planet even existed. This creates a profound sense of connection across both space and time. The same fundamental constant that governs the light from your bedside lamp also governs the ancient photons from the cosmic microwave background, the faint afterglow of the Big Bang itself. In a very real sense, we're all bathed in the same cosmic light, all participants in the same grand symphony of electromagnetic radiation. And yet, for all its cosmic significance, the speed of light also shapes the most intimate aspects of our daily lives. It determines how quickly information can travel from one place to another, setting the pace for our interconnected world. It governs the fundamental processes that power life itself, from the photosynthesis that feeds our planet to the visual system that allows us to perceive colour and beauty. It even influences our sleep patterns, as our circadian rhythms respond to the changing light throughout the day. This interweaving of the cosmic and the personal reveals something profound about the nature of existence itself. We are not separate from the universe, observing it from some distant vantage point. We are part of it, shaped by its laws, participating in its processes, connected to its deepest rhythms. The speed of light isn't just a limit on how fast things can go, it's a fundamental parameter that defines the kind of universe we live in, and therefore the kind of beings we can be. In many ways, the speed of light serves as a gentle reminder of both our limitations and our possibilities. We cannot travel faster than light, cannot send messages into the past, cannot escape the constraints of causality. But within these boundaries, we find extraordinary richness. We can build technologies that harness electromagnetic radiation. We can decode the messages written in starlight. We can use our understanding of light to peer deeper into the cosmos and further back in time than any previous generation. The speed of light also offers us a lesson in patience and perspective. In our fast-paced world, where we often expect instant results and immediate gratification, the universe reminds us that even the fastest thing in existence still takes time to get from here to there. Light from the sun takes about 8 minutes to reach Earth. That means the warm sunlight on your face this morning actually left the sun's surface when you were still having breakfast. There's something both humbling and comforting about this cosmic delay, a reminder that even the universe operates on its own timeline. Perhaps most importantly, the speed of light teaches us about the nature of limits themselves. We might initially think of limits as restrictions, barriers that prevent us from achieving our goals. But the speed of light shows us that limits can also be liberating. By preventing faster than light travel, this cosmic speed limit protects causality and keeps the universe logically consistent. By setting a maximum rate for information transfer, it ensures that cause and effect maintain their proper relationship. In constraining certain possibilities, it enables others. This paradox of constraint and freedom echoes throughout many aspects of life. Just as the speed of light gives structure to space-time, the limits we encounter in our own lives often provide the framework within which creativity and growth become possible. The rules of physics don't prevent beauty, they enable it. The constraints of language don't stifle poetry, they give it form. The boundaries of our mortality don't diminish the meaning of our lives. They intensify it. As we prepare to close this gentle exploration, it's worth reflecting on how the speed of light has served as both our guide and our destination. We began by asking why nothing can go faster than light, and we've discovered that the answer involves the deepest principles of physics, the structure of reality itself, and the delicate balance that keeps the universe comprehensible and beautiful. But we've also learned that the speed of light is not just about speed, it's about connection, about the flow of information and energy that binds the cosmos together. It's about the stories that light tells as it travels from distant stars to our eyes, carrying with it the history of the universe itself. It's about the invisible threads of electromagnetic radiation that connect us to our phones, our loved ones, and the farthest reaches of space. So tonight, as you settle into rest, remember that you are surrounded by light. Photons from your lamp, from the stars, from the gentle glow of your devices, all moving at the same fundamental speed, all participating in the same cosmic dance. The universe is not a cold, empty void, but a warm, interconnected web of energy and information, all flowing at the pace set by this one beautiful, immutable constant. The speed of light may be the fastest thing in the universe, but it's also patient enough to bring us starlight, gentle enough to warm our faces, and reliable enough to carry our messages across the world. In its constancy, we find both the order that makes science possible and the wonder that makes life meaningful. And perhaps that's the most profound lesson of all, that the deepest truths of the universe are not cold equations but warm realities that shape every moment of our existence. The speed of light is not just a number, it's the heartbeat of the cosmos, the rhythm that keeps time itself in step, the gentle pulse that connects every photon to every star, every eye to every sunset, every moment to every other moment in the grand tapestry of existence. We arrive now at the final moment of our gentle voyage through the mysteries of light and its unwavering speed. Throughout this journey, we've traced the path from ancient observations to modern revelations, from the first tentative measurements to the profound recognition that light speed isn't merely a characteristic of photons, but the very pulse that animates the architecture of reality itself. The speed of light, that sacred constant of 458 meters per second, emerges not as an arbitrary rule imposed upon the universe, but as the fundamental rhythm that weaves together space and time into the unified fabric we call space-time. It is the cosmic metronome that ensures causality flows in its proper direction, preventing the paradoxes that would arise if effects could precede their causes. This speed limit doesn't constrain the universe, it liberates it, providing the structure within which all physical laws can operate harmoniously. We've seen how this limit shapes everything from the grand cosmic dance of galaxies to the intimate biological rhythms within our own bodies. The light from distant stars carries not just illumination, but information, stories written in wavelengths that tell us about the chemical composition of worlds we'll never visit, the birth and death of stellar giants, and the very origins of the cosmos itself. Every photon that reaches our eyes has travelled its maximum possible speed through space and time, carrying with it the history of the universe. The constancy of light speed has revealed to us that time is not the universal, flowing river that Newton imagined, but something far more mysterious and personal. Time dilates with motion, stretches in gravitational fields, and flows differently for each observer, depending on their velocity and position in space-time. Yet through all these relativistic effects, light maintains its steady pace, the one constant that remains unchanged no matter how fast we move or how strong the gravitational field around us. Perhaps most remarkably, we've discovered that this speed limit isn't just a cosmic curiosity, but a practical reality that touches every aspect of our daily lives. From the GPS satellites that guide us through unfamiliar streets to the fibre optic cables that carry our digital conversations across oceans, from the fundamental processes of photosynthesis that sustain all life to the circadian rhythms that regulate our sleep and waking, the speed of light is woven into the very fabric of existence on Earth. The electromagnetic spectrum, of which visible light is but a small part, reveals the profound unity underlying seemingly disparate phenomena. Radio waves, microwaves, infrared radiation, visible light, ultraviolet rays, X-rays and gamma rays are all manifestations of the same fundamental entity, electromagnetic waves, all travelling at the same speed through the vacuum of space. This unity suggests something beautiful about the underlying simplicity of natural law, how a single principle can manifest in countless ways. We've explored the various attempts to circumvent or exceed this cosmic speed limit, from the theoretical tachyons that exist only in equations to the speculative warp drives that might bend space-time itself. Yet each potential loophole reveals new complications, new reasons why the universe seems determined to preserve this fundamental constant. Even quantum entanglement, that spooky action at a distance that Einstein found so troubling, respects the speed limit by refusing to transmit usable information faster than light can travel. The story of how we came to understand light speed is itself a testament to human curiosity and ingenuity. From Galileo's charming but futile attempt to measure light speed with lanterns on hilltops to the sophisticated laser interferometry that now defines our very units of measurement. Each generation of scientists has built upon the insights of their predecessors. This accumulated knowledge has led us to recognize that the speed of light isn't just something we measure, it's something we use to define measurement itself. As we stand at the threshold of new technologies that promise to decode dreams, manipulate the flow of time, or peer ever deeper into the quantum realm, the speed of light remains our faithful companion. It ensures that information, energy, and causality flow in their proper channels, maintaining the logical structure of reality even as we push the boundaries of what's possible. This cosmic speed limit is not a barrier to human achievement, but a guardrail that keeps the universe comprehensible. The profound implications of light's speed limit extend beyond physics into philosophy and meaning. If we accept that nothing can travel faster than light, we must also accept that we live in a universe where patience is built into the very structure of reality. The stars we see tonight are showing us their past, not their present. The light from the most distant galaxies has been travelling toward us for billions of years, carrying news of cosmic events that occurred when the universe was young. We are, in a very real sense, archaeologists of light, studying the ancient photons that have journeyed across space and time to reach us. This cosmic archaeology reveals something profound about our place in the universe. We are not separate from the cosmos, observing it from the outside. We are participants in its ongoing story, made of elements forged in the nuclear fires of ancient stars, sustained by the energy of our own star, and connected to the rest of the universe through the constant rain of photons that surrounds us. The speed of light is not just a physical constant, it's the speed at which the universe communicates with itself, sharing information, energy, and ultimately, meaning. The beauty of this cosmic speed limit lies not in its restrictions but in its revelations. It tells us that the universe has a deep, underlying order, that there are rules that govern even the most fundamental processes of nature. These rules are not arbitrary or capricious, but elegant and consistent, creating a cosmos that is both comprehensible and awe-inspiring. The speed of light stands as a testament to the mathematical beauty that underlies physical reality, a reminder that the universe speaks in the language of mathematics, and that we, through patient observation and careful reasoning, can learn to understand that language. As we contemplate this vast cosmic symphony, with its rhythm set by the speed of light, we might find a certain peace in knowing that we are part of something larger than ourselves. Every heartbeat, every breath, every thought occurs within the framework established by these fundamental constants. We are not isolated beings struggling against an indifferent universe, but integral parts of a cosmic story that has been unfolding for billions of years and will continue long after we are gone. The speed of light reminds us that the universe is patient. It doesn't rush to deliver its messages or hurry to complete its processes. Starlight takes years to reach us. Galaxies slowly wheel through space, and the cosmic microwave background carries whispers from the universe's earliest moments. This patience suggests that perhaps we too can learn to move through life with a similar grace, accepting that some things cannot be hurried, that some journeys take time, and that some truths reveal themselves only to those who are willing to wait. In the end, the speed of light is more than a physical constant. It's a metaphor for the limits and possibilities that define our existence. It reminds us that while we may dream of infinite speed and instant communication, there is profound beauty in the constraints that shape our reality. These constraints don't diminish us, they define us, giving structure to space and time, meaning to causality, and rhythm to the cosmic dance in which we all participate. So the next time you see sunlight streaming through a window, starlight twinkling in the night sky, or even the gentle glow of a candle flame, remember that you are witnessing one of the universe's most fundamental truths in action. Those photons have travelled to you at the maximum possible speed, carrying with them the story of their origin and the promise of connection. They remind us that in a universe governed by the speed of light, we are all, in the most literal sense, children of the stars, bound together by the same cosmic rules that govern the dance of galaxies and the dreams of atoms. The speed of light is not just the fastest speed possible, it's the speed at which the universe becomes itself, moment by moment, photon by photon, story by story. And in that gentle, constant flow of light through space and time, we find not limitation, but liberation. Not constraint, but connection. Not the end of possibility, but the beginning of understanding. This is why nothing can go faster than the speed of light. And perhaps, in the quiet wisdom of the cosmos, this is exactly as it should be.